Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Today we are going to know about definite integrals as limit of sum. We already know that the goal of integral calculus is to find area under a given curve. Or we can say that integral a to b fx dx is the area under curve fx between two given points a and b. That is, the area under curve fx between two given points a and b is equal to the value of the integral a to b fx dx. Let us try to understand it this way. Let y is equal to fx be a function, and let this curve represent graph of the function y is equal to fx. We have to find area under this curve between two given points a and b. That is, we have to find area of this bounded region, that is area under curve y is equal to fx and between two given points a and b. Okay, now we complete a rectangle here. Now we can easily find area of this rectangle as this side is equal to b minus a. b minus a is length of this side, and length of this side is equal to f of a. When x is a, we get y is equal to f of a. So this side is equal to f of a. Thus, area of this rectangle is equal to b minus a into f of a. But there is much area left outside this rectangle, that is area of this region. So we can say that area of this rectangle is not good approximation for the area under curve between two given points a and b. Now let us take two rectangles instead of one. Now we have two rectangles, and let they are of equal width. Now we can easily find area of these two rectangles. Clearly, the summation of areas of these two rectangles is better approximation for the area under curve between two given points a and b than area of one rectangle. Although there is some area left outside these rectangles, but this area is much less than the area that was left in case of one rectangle. If we increase the number of rectangles, then the area left outside these rectangles will definitely decrease. Now instead of two rectangles, we take n rectangles. Okay, now let x1 is equal to a, this is x2, and so on. Now to draw n number of rectangles, we have to draw n plus 1 vertical lines. So in that case, b is equal to xn plus 1. Let's complete these rectangles. Also, let width of each rectangle be equal to h. Okay, so we can write, if x1 is equal to a, then x2 is equal to a plus h. A plus h, and x3 is equal to a plus 2h. It is x3 here, is a plus h, that is 2h, and so on. Similarly, if it is xn plus 1, that means this is xn, so xn is equal to a plus, now in case of x3 we have a plus 2h, that is 3 minus 1, and here is x2, it is a plus 1h, that is 2 minus 1. So in case of xn we can write it as a plus n minus 1h, and xn plus 1, or we can write xn plus 1 or b, xn plus 1, which is equal to b, that is equal to a plus nh, or we can write b is equal to a plus nh, or b minus a is equal to nh, or nh is equal to b minus a. Thus we have nh is equal to b minus a. Now we will find area of these rectangles. Now in case of first rectangle, width is equal to h and its length is f of a. As x1 is equal to a, so its length is f of a. You put x equal to a, you will get y is equal to f of a. Therefore area of first rectangle is width, that is h, into length, that is f of a. Similarly, in case of second rectangle, again width is equal to h and its length is equal to f of a plus h. As x2 is equal to a plus h, so its length is equal to f of a plus h, and so on. So we can write sum of areas of n rectangles is equal to, area of first rectangle is h into f of a plus area of second rectangle is h into f of a plus h plus area of third rectangle is h into f of a plus 2h plus so on. Area of nth rectangle, this is equal to h, it is h into f of a plus n minus 1h, or we can write it as, this is further equal to sum of areas is equal to, it is summation h f of a plus rh, where r is running from 0 to n minus 1. Okay, now clearly the summation of areas of these rectangles, that is summation r running from 0 to n minus 1, h times f of a plus rh is not equal to the area under curve between two given points a and b, as there is some area still left outside these rectangles, that's area of these regions. Okay. Now, if we increase the number of rectangles, that is, if we take n very very large, or we can say when n approaches to infinity, in that case, width of each rectangle is reduced, or we can say when n approaches to infinity, h approaches to 0, h becomes very very small, h approaches to 0. So as you increase the number of rectangles, the width of each rectangle decreases. In that case, the summation of areas of these rectangles approaches to the area under curve between given points A and B. Okay, so we can write area under curve y is equal to fx between points A and B, that is integral a to b fx dx is equal to limit n tends to infinity or h tends to 0, summation r running from 0 to n minus 1, so we can write h here, which is h times f of a plus rh. Okay, now this is the area under curve y is equal to fx between two given points a and b, and we can represent this area by this integral a to b fx dx. Okay. Now in my next lecture we will do some questions based on definite integral as limit of sum. Till then, take care of yourself. Thank you.